Hi everyone, my name is King Solomon, and I have another brother who also come on this platform, which is also called David Brown Piposi. So I'm a project student and he's a research assistant in an institution. Basically, what we are doing here is that we want to make you guys understand the whole concept about applied electricity. Now we understand that applied electricity is a course that is studied at the universities, especially for engineers, because if you want to grow in your aspect of an engineering, that is specifically maybe let's say materials engineering, telecommunication engineering, civil engineering, mechanical engineering, electrical engineering, your basis or the courses that you can do at your basis to improve upon your specific aspect of the engineering, you need applied electricity and some other courses. So what we are doing here is that we want to make you guys understand the whole concept about applied electricity. And in Ghana here, that is KNUSC. The course code for this course is EE151. So without wasting my time, I'll just take you guys through the introduction. That is the circuit and network theorems in applied electricity. Now my outline for this particular lesson is, first of all, I'll talk about the definition of a circuit, elements of an electric circuit, the nodes or junction in a circuit, the part of a circuit, the branch, the loop, short circuit, and an open circuit. So, dealing with the definition of a circuit. Now, when you say a circuit, what do you mean by a circuit? A circuit is simple, an interconnection of elements that is formed along a closed path in which current can pass through. So now, I'll have, for instance, a conducting wire on my wire. And in the conducting wire, I might connect some resistance, I might connect some voltage, I might connect some loads. So let's say this is a load. I might connect some batteries. That is the voltage, the battery produces the voltage. And I'm connect other elements. Now when you connect all these elements together, by the help of what? A conducting wire, you form what we call a circuit. So now this here is a typical example of a circuit or a simple circuit because I've interconnected some elements here that is capable of allowing current to pass through it. So this here is a circuit. Now, what are the elements of an electric circuit? Basically, the elements of an electric circuit are in two. So if you want to deal with the elements of an electric circuit, they are in two. So this element one, we have what we call the active elements. And we have the passive elements. Now, when we talk about the active elements are simple, the energy producing elements. That is simply elements that produces energies. So now the energy producing elements, some of the examples are the solar cells. You have also generators. And we have our normal batteries we use. So these are some examples of the active elements because a battery will produce an energy. Solar cells also produce an energy. And generators also produce an energy. Some can produce the energy by means of chemical, some produce the energy by means of electricity. So these are all active elements. Now when it comes to the passive elements, the passive elements are simply the energy using elements. So now the energy using elements simply means that elements that use the energy, they don't have the capacity or the ability to produce energy, but they are elements that use the energy. And a typical example is capacitors. You have inductors. You have resistance, and other elements. So now these elements, they intend to use the energy. So for instance, the resistance will reduce the current flow. The resistor will reduce the current flow, and that terminology is known as the resistance. Now the capacitor will also store the electric charges, and the inductor is meant for inducing the charges. Now, okay, so now, according to the outline, we like to do with the notes in the past, but to actually explain it, I want to use this circuit diagram to explain what a node is, and also to explain what a path is. So simple. When you say a node is simple a point where current splits or come together. So now that is a node. So a node is simple a point in the electric circuit where current splits or come together. So now, when you check this electric circuit, points of this electric circuit are about 8. That is A, B, C, D, E, F, G, and H. But not all these points can be classified as a node, because when we take A for example, A cannot be a node because A, there's no current split or current coming together in A, because the current that passes through here, so let's assume the current that passes through I, the A, is I1. It's the same current that will go through, always going through A. There's no current split or current coming together. But when we get to B, the current I1 that is coming to B will now split into two. So we now have current I2 and some amount of current, let's say I3, also going towards G. So at this point B, there is a current split. So current is splitting at point B. When it comes to the same as point C, the I2 that is coming might also branch into I4 and some branching into the I5. So at point D2 there is what? A current split. Now, at point D, the current that passes through point D is I4. It is the same current that passes through here. So at point D, there is no current split or current coming together. So point D is not a node. The same as point A is also not a node. But point B is a node, and point C is a node, because we experience current split over here. Now, when you come to point E is not a node because the same current I4 will go through. Now, to point F, we realize at point F, there is current I4 coming, and there is current I5 also coming. So, point 4, now current comes together in point 4. So, in point F, so point F is also a node, because we explained that the currents are coming together. Current that comes here, that is okay. So I2 was I4 and I5. So if I4 and I5 are coming together, the current that comes here is I2. So now I2 will come, when we get to point G, it is I2 coming and I3. Now I2 and I3 is at point G, I2 and I3 are coming together to produce back I1. So at point G2 there is what? Current coming together. So point G is also a node. But when it comes to point H, it's not a node because there is no current split or current coming. So now the nodes we have in this circuit is one, point B, point C, point F, and point G. So these are the nodes we have in this very circuit. A point where current split or current come together. Now in short, let's explain what a path is. A path is simple, a connection within the circuit where current flows. So any connection within this circuit where current flows is a path. So now when we check between A and B, current flows between A and B. So A and B, so path. You can have AB, which is a path. We'll also check within B and C, it's also a path because current flows between B and C. So B and C can also be a path in this circuit. And There are a lot of parts within this circuit. You check between what we call J, H is a part, and G is a part because there's current passing through those various circuits. Now, let's go to what the branch is. Now, from this very circuit, if you want to understand a branch is simple. A branch is a connection or a path between two nodes. A connection or a path between two nodes. So now, if you want to identify a branch on this particular circuit, how many nodes did we identify here? 4. So any connection between these two nodes is a branch. So now we can have B, C, which is a branch because it's a connection between these two nodes. We can have B, A, H, and G. It is also a branch. Why? Because it is a connection. This whole is a connection between these two nodes. That is B and G. It is also a branch. We can also have G and F, which is also a branch. So any connection that exists between two nodes is a branch. And loop. The loop or the mesh. Now, the loop or the mesh is simple. So if you want to create a loop within this circuit, now you can assume that is to say simple. Let me just explain it simple. Where you start from, the point where you start from the circuit, the electrical circuit, to draw a loop, you should end that same point when you are ending or closing the loop. So now, when I start with A, when I want to create a loop within only this region of the electric circuit, when I want to create a loop and I start from A within the region, I have to close the loop with the same point A. So I take the example of a loop I can create within this region is loop A, B, J, H, A. This is an example of a loop I can create within this circuit. I can also create a big loop around the whole circuit. If you want to close such a loop, it becomes A all the way to this point D, to this point E, to this point H, and back to what? The A. I can also create another loop only within this region. So I start from maybe C. So I create C, D, E, F, and back to C. The same region I can go anti-clockwise, either clockwise or anti-clockwise. So I can also go starting from D. So D, C, F, E, D. So this is the explanation of what a loop is. Now, the last thing we'll do